Alright, today we're going to kind of switch gears from what we've been doing with the inverse and other types of function, composite functions, adding, subtracting, multiplying, dividing functions, and we're going to go to um, variation problems. So this is still dealing with polynomials, and it's still solving, except for now variation I think is one of the easier lessons once you get the hang of it. So we're going to know the functions can be used to model real world situations. We now want to look at some models that follow special patterns, and we call those variation. Alright, so there's direct, inverse, and joint. To motivate the idea, let us consider a couple of situations, identify the variables in each, and identify the relationship between them. So wages at a job, right? Normally you're going to sit there and say, oh yeah, money and like hours you work. Okay, that's going to be relationship. Area is going to be like length, width, dimensions of it, really is what you're thinking about. Like that's the comparison of that. Time as a function of rate. So really what it is like time, and then it's like gallons per minute or whatever it is. So these are just some examples to get your brain kind of thinking about what we're doing. Don't think too much into that, guys. Instead, I really want you to focus on this. So the statement y varies directly as x or y is directly proportional to x means that we're just going to multiply. So directly just means multiply. All right? The k constant is the constant of variation or constant of proportionality. You're going to have a k in every single one of these problems, so just get used to seeing that. And we'll talk about that whenever we do some examples. Varies inversely. Inversely means division. Right? The formula for that is y equals k over x. And then varies jointly means I'm just going to multiply by more than one thing. Okay? So again, those example equations, these are just examples. They do change quite a bit though. What I really want you to focus on is what are we doing here? So translate the following statements into function form. So first thing I want to talk about is anytime you see varies or is, that's an equal sign. You need to know that. So get in the habit of that. All right? So this first one says g varies directly as the cube of n. Let's talk about this. G varies. So right there I'm going to say g equals. Now I told you every equation, no matter if it's directly, jointly, or inversely, it's going to have a k in it. So after I write g equals, I always write k. So after your equal sign, you always write the k constant. Now, we just look at the rest of the problem. Directly means I'm going to multiply. Cube of n means n to the third power. So that means multiply. And it's cube of n, so I'm going to say n to the third. And that's how you would write your equation. Now, we'll look into solving it later on, but you need to make sure you understand how to write it. Okay? So b, if I go down, it says v is, so v equals, because is my equal sign, inversely proportional to p. So inversely means I'm going to divide, and proportional to p just means I'm going to use p. But remember, after every equal sign, I write a k. I'm going to divide. Now I'm going to divide by p. Okay, next one says c varies right there. We know c equals. I'm going to write my k. Jointly means I'm going to multiply as h and the square of r. So r squared. So we're going to say h times r squared. And the last one, I try to combine two things. So it says y varies. So y varies. So y equals directly as x. Okay. So after my equal sign, I write that k. Directly means I'm going to multiply by x. And inversely as a square root of z. So now I'm going to say divided by the square root of z. Because inversely means division. So you can have directly and inversely in the same problem. It's just you got to make sure you recognize, all right, am I multiplying or dividing? So then it says, suppose y varies directly as the square of x and inversely as z. If y equals 40 when x equals 2 and z equals 5, find y when x equals 4 and z equals 3. So that was a lot to digest right there. But the first thing I want to do is just let's go in order. Suppose y varies directly as the square of x and inversely as z. So let's write an equation. So y varies, so y equals, I'm going to write my k, because after my equal sign I always write k, directly as the square of z, so it's going to be x to the second. I'm going to multiply because directly, and inversely of z means I'm going to divide everything by z. So I want to write my equation first. Now what they're going to do is they want you to solve for k first. So whenever we solve these problems, we always find the constant first. So it says if y equals 40, so 40 equals, now I don't know what k is, when x equals 2, so I'm going to say 2 to the second power, over when z is 5. So z is 5. So now I'm going to solve this. I'm going to multiply both sides by 5 to get rid of that dividing by 5. So I get 200 equals k times, now what's 2 squared? Well, that's 4. And now to solve for k, I would divide by 4. So 50 is my k. All right? And that's an important step. We found k. Now it's going to say, this is the real problem. It says find y when x equals 4 and z equals 3. So I don't know what y is. I'm going to plug in my k. I know x is 4. I know z is 3. And I just solve it. Well, 4 squared is 16. Times 50 gives me 800. And then I want to divide it by 3. And you're going to want to round it to the nearest hundredth. So I'm going to say 266.67.
Logan Bates, come to the office. Logan Bates.
And that's how you solve a variation problem. So first off, we wrote them. Now we kind of get into the solving aspect of it. You write the equation like we did before, but then you got to solve for the constant and then solve for whatever they want you to solve for. So you're going to see word problems. Might as well get used to it. It's the same thing though. It says the distance a ball rolls down an inclined plane is directly proportional. So you see that keyword is? That's going to be your equal sign. So the distance, so I'm going to say D, a ball rolls down an inclined plane is, so equals, directly is a keyword. That means I'm going to multiply. Proportional to the square of the time it rolls. So square of the time. All right, so distance D equals K, and I'm multiplying by T squared because it's time squared. So it says during the first second, so that's a 1, the ball rolls 8 feet. So I'm going to say 8 equals K times 1 squared because I want to solve for K. So 8 equals 1K divided by 1. Your constant is 8. Now how far will the ball roll during the first 3 seconds? So I don't know the distance on this one, and this is what they're trying to get us to answer. But I know my constant is 8, and I know my time is 3. So I'm going to say 8 times 9, and I'm going to say 72 feet is what I end up getting.
Good morning.
Okay?
Students and staff are encouraged to stop by the counseling center this week and pick up a 100-gram candy bar.
So the number N of square tiles needed to tile a floor is, so they give us the number N. So N is, okay, inversely means I'm going to divide proportional to the square of the length. So that's on me. So my number is 180. So my constant was wrong. We're going to go back and we're going to resolve this. 6 squared, K over 36. All right, because it says inversely. I'm going to multiply both sides by 36. I'm going to K is 6,480. So now it says 9-inch side, so we're going to use that 6,480, but now we're going to do 9 squared. So we're going to divide it by 81, and we should get 80 tiles. And if you think about it, if they're bigger squares, it should take fewer tiles. All right? Next one, it says the cost of constructing a 9-foot by 12-foot patio is $734.40. If the cost, so C, varies, that's my equal sign, jointly means I'm going to multiply. As the length and the width, that just means I'm multiplying by L and W, then what does an 8-foot by 14-foot patio cost? So we're going to say C equals KLW. So my cost is $734.40. Remember, we always get to solve for K first. K, and it's 9 times 12. So 9 times 12 gives me 108. So $734.40 equals 108K. Divide by 108. I get 680. So 6.8 equals my K. So now we take that and we're going to rewrite the equation and figure out how much does it cost for an 8 by 14 foot patio. So then we're just going to multiply all of it. And I get $761.60. Again, it's a little bit bigger patio area-wise, so it makes sense that it costs a little bit more. So the time t required to process a shipment of oysters varies directly. So time t, there uses my equal sign. Directly means I'm going to multiply with the number of pounds p in the shipment, and inversely means I'm going to divide with the number of workers w. So I'm going to say t equals, we have our k, the number of pounds p, so we multiply by p, and inversely as the workers assigned, so we're going to divide by w. So if it takes 8 hours for k times 3,000 pounds divided by 6 workers, we're going to solve this. So we're going to get 6 times 8, 48 equals 3,000k, because we're multiplying on top. So then I'm going to divide by 3,000. My k is 0.016, really small number, and that's fine. So then it says, how long will it take 5 workers to process 4,000 pounds? So we don't know the time yet, but we know our k now. 4,000 pounds divided by 5 workers. And that was going to take 12.8 hours. And it makes sense. You have more weight, fewer workers. It's going to take longer, right? So that is how variation problems work. If you guys have any questions over that, make sure you ask, reach out, get some extra help. Your homework is going to be Certified 3.4. This is the one that we skipped, so these are variation problems 3.4. And just make sure you answer the question when it's asking for. I think it's a really short one, and you should be able to get the Hawks done pretty easily. Again, if you're struggling with this, just let me know. I'll be more than happy to help set up a tutoring time. Otherwise, have a great day, guys.